Hello? Hello, Mr. Eric, Mr. Ryan, are you alright? Are you alright? Yes, okay. Okay. Okay, that's it. So, okay, we have been talking about this problem. Where's my pen? Okay, it's my pocket, okay? We have been talking about this problem. Okay, so can you explain what's the problem?
We have this list of numbers thingies and we want to find duplicate of.
Well done. Yes, exactly. Okay. So we are given this array, which is size of 2n, and there's n plus 1 unique numbers. And only one number appears n times. Okay? And the size is 2n. So n times, it means that 50% of the numbers is duplicate, is one single number. Okay? So for example, 1, 2, 3, 3. What is the number we are looking for? 3, right? Because 3 appears 50% and it's only number which appears n times. 2, 1, 2, 5, 3, 2. We are looking for number 2 because 2 appears 3 times, right? 3 times 50%. Okay? So we have talked about using the hash set to remember. This is a data structure to remember the number we have seen. This is easy, trivial, okay? To sort the numbers, when we sort the numbers, the time complexity is
Log n.
log n, yeah. So when we sort it, we can compare the neighbor numbers, right? We can compare the neighbor numbers, so to find out if it's a duplicate, okay? Yeah?
It's magic, Dad.
Okay. And then last lesson we talk about using the math. So basically we can get the sum of all the numbers, right? And then we use the set, right? We use the set so we know the number, the n plus 1 unique numbers. And then we can calculate the sum for this part. Sum all the numbers minus the sum of the unique numbers and divided by n minus 1. The duplicate numbers, there's 1 included in this bit, okay? The time complexity for this one is ON. So today we talk about the random. What's random? What's random? Explain the word. What's random? What's random?
Random means RANDOM.
Yeah, what does it mean? What does it mean?
That it could be random.
So okay, what's random? Come on, explain this. What's random?
It's unpredictable. Yeah.
Unpredictable. Okay. So yes, unpredictable. Okay. So
Poke.
okay. Don't ruin my camera. Okay. It's still rolling. Okay.
Of course it is. It's a camera.
Okay. So let's see. We have talked about many solutions, many algorithms to sort numbers, right? Sort the array. Remember? The quick sort. Yeah? The merge sort. The bubble sort, right? Yeah? The quick sort, ON log n. The bubble sort, ON square. Okay? So there's actually a very interesting sorting algorithm which is called monkey sort. Okay? Or called the Bogo sort. Bogo. So what does it mean? Simple. Given this number, right? For example, this number 1, 2, 3, 3. And maybe a few numbers, right? 2, 3, 4, 1. Okay, these 4 numbers. Yeah, 4 numbers. Suppose a monkey has these 4 numbers.
Monkey's from jungle.
What's jungle?
Juggle, I mean.
Okay, so these 4. So there are 4 balls, right? 2,
Monkeys live in the jungle.
3,
Juggle.
4, 1. Okay, so these 4 balls labeled with numbers, and the monkey, knows how to throw the balls into the air. And every time it throws, it do a shuffling, right? Shuffling, and then
Monkeys don't know how to do that.
Suppose it knows. And then when it finishes,
Hey, did you know
these
that
balls.
Did you know that 2 bodies are found in the river Thames?
Okay, so the monkeys do this. And then when it finishes, these balls
Monkeys can't
must be
juggle.
arranged in some order. Okay?
Monkeys can't juggle.
Okay, suppose it does. Okay?
It should
So-
be humans that juggle.
So
Clown. It should be annoying.
at some point, these 4 balls, these elements must be in order. Okay, but it depends on this probability. Okay, so simple. The pseudo for Bogo sort is define
Is that what you
Bogo
said, Bogo?
array.
I think Bogo.
Okay, while when the array is not sorted, let's say we have function is sorted, it's not sorted, then we do this random dot shuffle. We talk about the shuffle algorithm, right? Shuffle array. So basically, that's the algorithm. Okay, that's the algorithm. When the array is not sorted, then we shuffle it. We just randomly. Yeah, you know what's the word shuffle? We shuffle means that to random arrange the order, right? Okay. What's the time complexity for this one? It's very tricky.
There's O1. O-N.
No.
O-N log N.
In the worst case.
Log N.
No. Okay. So in the worst case, this could never happen, right? Suppose the monkey, you shuffle it, but it never gets order, right? It has this probability. So this is kind of like in the worst case, it never gets sorted. So
squared.
Infinity. Okay. Make sense? Does it make sense? In the worst case, when we talk about complexity.
Why do you want to sort it?
This is just saying that, okay, we want to sort this array, right? Then let's just check. If the array is not sorted, then we shuffle it. Okay? Good catch. Okay, so why we talk about this random sorting? This is one classic random algorithm, okay? So, but this is definitely not the practical sorting algorithm. We are talking about here is that we want to find out the duplicate number, right? But since the number appears 50% of time, so we can pick one random index, for example, like 2, 3, 4, 1, 2, 2, okay? So we know already this 50% of the number is duplicate. So let's pick one index, which is A, okay? So what's the probability of picking the number we want? I just told you 50% of the numbers. 50%. Yeah, 50. Yes, 50%. Okay, and let's pick another index. Okay, let's pick another index. What's the probability of it being the number? We are looking for. Another 50%, right?
25%.
Yeah. So times it is 25%. Okay, but the index could be the duplicate. If we want to pick the number, we want to pick the index. And the second time we pick the index, it could be the same index. We don't want that, right? We don't want that. Okay, so the algorithm becomes that. Okay. So we want to pick two index, and we want to check if they are different. And then if they return the same number, then we're looking for it. Okay, so anyway, so we pick two index. Okay. So let's say while choose, pick one index random. We use the random function, random library called random.randin. Alright? Index, right? The index n-1. The n-1, n equals the length of the index array. We pick the index. So this function means that we want to pick a random integer from 0 to n-1 inclusive. Okay, inclusive. Rand in, this is inclusive from a random number from this A to B inclusive. And another function called range, which is the range. You know the range function? Yeah, start, stop, step. Okay, so range. And another index, random. We pick another index. Didi, what you doing?
This needs charging. It's not charging.
Okay, just put it there. Can we focus on this, please? Okay. We pick first index. We pick another index. Okay. And if these two index is not the same, right? We can't pick the same index, right? If these two index are not the same, and these two numbers are the same. Okay, so then we return this number, right? Simple. Why this approach is okay for such a problem? Because 50% of the chance we can pick the number, right? 25% actually, okay? Right? Because the first time we pick this number, so
Dad, it's taking forever.
Random function, okay? So random. The first time we pick one number, pick a random number. Second time we pick another random number. And as long as the index are different, we pick two numbers. Basically, this is saying that we pick two different numbers and we pick two different index. And these two index, if the numbers are the same, then this is the duplicate, right? Because as we know, 50% of the chance we can pick the number we can pick a duplicate number. And the second time is still 50% of chance. So the overall probability is 25%. Okay, but this is less than 25% because we still have chance of picking two index which is not the same, right? For example, we pick the first number, the second time we still pick the first number. There are two, and the probability of picking the first index is this one, right? And then if the second time we can still multiply the probability. Okay, this is the probability of picking the same index twice. Okay, so what's the time complexity for this one? In the worst case, infinity. Why? Because in the worst case, the favor is not on your side, right? You'll be picking the unique numbers every time. Okay, and then this loop, this will be the endless forever loop. Okay, so this is one interesting way of solving the problem. If the chance is high, we can use this problem because this is quite simple. Okay, let's see for today. Bye bye.
Bye.
Bye bye.